Welcome to Lessons in Logic, video number 45. It's like the Energizer Bunny. This thing keeps going and going. And for our natural beauty to accompany the beauty of logic that will go in the lower right corner of the screen, we have a sunset picture from Sinyati Baptist Mission's Dam and Pond. Probably my father took this picture in the 90s. I can't promise it still looks like that. I'm sure there's a different set of trees if nothing else has changed. Anyway, let's do a proof for Socrates' argument. Let's return to this argument from Plato's Apology, and let's prove that it's a valid argument. So let's start by symbolizing the argument. Now, I'm going to make this a little simple and just use what I just worked up in an earlier botched attempt to record the video. But let's read the argument and then look at the symbols. Either there is life after death or there is not. If there is not, then death is just the end of experience. If death is the end of experience, then there's no suffering after death. If there's no suffering after death, then there's no point in fearing death. If there's no life, if there is life after death, then we need to be good no matter what. Either way, there's no point in committing some injustice to save our own lives. Now, the atomic propositions in this argument are: there is life after death. Death is the end of experience. There is suffering after death. There is a point in fearing death anyway. We need to be good no matter what. And there's a point in committing some injustice to save our own lives. And the argument symbolized is this. Without pausing to review what all the symbols mean, I guess I'll read it in just pure symbols, and then I'll read it without the symbols, and then I'll maybe scroll up and make sure this looks right. L wedge tilde L. Oh, wait. I haven't stated what those atomic propositions are symbolized as yet, have I? Well, you can presumably see it on the screen, but there's life after death is L. Death is the end of experience, E. There's suffering after death, S. There's a point fearing death anyway, F. We need to be good no matter what, G. There is a point committing some injustice to save our own lives, I. So the argument is L wedge tilde L arrow E, E arrow tilde S arrow tilde F, L arrow G, and then open parenthesis, tilde F wedge G, close parenthesis, arrow tilde I, therefore tilde I, which means either L or not L. If not L, then E. If E, then not S. If not S, then not F. If L, then G. If either not F or G, then not I. Either way, not I. In other words, either there's life after death or there's not. If there's not, then death is the end of experience. If death is the end of experience, then there's no suffering after death. If there's no suffering after death, then there's no point in fearing death anyway. And if there is life after death, then we need to be good no matter what. For religious reasons, check the text of Plato. And if either there's no point in fearing death anyway, or we need to be good no matter what, then there's no point committing some injustice to save our own lives. Therefore, there's no point committing some injustice to save our own lives. Now, you can pause, rewind, scroll up, whatever. I'm scrolling up, you pause at the right point, and you can see, or you should be able to see, unless I made some horrible mistake or you're confused for some reason. Either could happen, I suppose. But you should see that this symbolization, using these abbreviations, perfectly captures this argument. One thing might need clarification. Our last statement here, note how in the original, we numbered our conclusion number 6, but it has this either way, which points at a statement that's not quite explicit, a premise that's implied but not explicitly stated. That premise is actually premise number 6, and the conclusion should have been given a different number. That premise is tilde F wedge G arrow tilde I, with parentheses around the tilde F wedge G, meaning if either there is no point fearing death anyway, or if we need to be good no matter what, then there's no point committing some injustice to save our own lives. Either way, there's no point committing some injustice to save our own lives. That's the implied premise that finishes up the argument. So now we just need to do a proof of this argument. Now, I don't think there's any simple or obvious way of doing this without a constructive dilemma step. Actually, I'm almost certain there is a way, but I'm not going to do it. Let's not do anything fancy. Let's just do a simple constructive dilemma. Now, you could do that, actually. You could just start where a constructive dilemma makes sense, which is to say, look for things that fit the pattern of constructive dilemma. L or not L? If L, then G. If not L, then E. And that'll give you either E or G. and then you could do some other magic to get to the conclusion. Although it might be better to do hypothetical syllogism first. If tilde L, then E. If E, then tilde S. If tilde S, therefore tilde F. And with two hypothetical syllogism steps, you can get if tilde L, then tilde F. And then you can use your tilde, if it tilde L, then tilde F, plus your L or not L and your if L, then G to get tilde F or G. Actually, G or tilde F. But then you can switch around G and tilde F and G. You can switch them around with whatever that rule's called. My brain's freezing up the title of the rule, which is kind of annoying. Commutation, maybe it's called commutation. Anyway, I don't recommend this approach. It's fine. It'll almost certainly work. But I recommend working backwards. How are you going to get to the conclusion tilde I? Well, obviously from this premise. If you can first get this antecedent, then you can get the consequent. This is an if-then premise. Your conclusion is the then clause of the if-then premise, premise 6. That particular if-then premise. You've got a lot of if-then premises. Your conclusion is the then clause of an if-then premise, premise 6, so you just need to get the if part. The if part is tilde F or G. How are you going to get that? Well, if you had tilde F or G all by themselves, you could say tilde F or G by the addition rule. Or if you had tilde F or G together, then you've already got it. So how are you going to get G and tilde F? How are you going to get G or tilde F? Well, you could get it from getting tilde S or L. Now, L doesn't come from anything else. The only other place to look for L is up there. But if you're looking for tilde S or L, you're going to need to do some other steps to get to tilde S. Tilde S is going to come from E. So if you're going to get to tilde F or G in order to get to the conclusion tilde I, you're going to need to get to E or L, except that's not deep enough. You need to go a little deeper. E comes from tilde L. So in order to get to this tilde F or G, you're going to need L or tilde L. And ta-da, we have L or tilde L, which means it looks like constructed dilemma is exactly where we want to start. Except I'm actually seriously worried about how this might go wrong. But let's try it and see what goes wrong. Let's do a simple constructive dilemma on lines 1, 2, and 5. Constructed dilemma on lines 1, 2, and 5. L or tilde L. If tilde L, then E. If L, then G. That tells us either G or E. Now, how do we get from G or E to our final conclusion? Well, we're going to use G or E to somehow get to G or tilde F, and somewhere around there we have to switch around. I think it's called commutation. Tilde F or G or tilde F to get tilde F or G. Either or propositions don't mean anything different if you switch the ordering of them, but we have to do that in its own separate step of the proof. But then how do we get from G or E to tilde F or G? Let's see. I can think of one way to do it, which is a nice conditional proof. Another way we could do it is some form of constructive dilemma. We could do some clever work with addition and maybe a material implication rule and a constructive dilemma, but this is a terrible idea. Let's just not even try. Here's what makes sense. We can do a conditional proof. This is not the best strategy, but I'm going to do it anyway. All right, I got to straighten out my formatting because it doesn't want me to indent. It doesn't want me to indent. Okay, this feels right. Let's do a conditional proof. But not yet. Let's first switch them around, because I can see we're going to need to do that later. And it doesn't do any harm now. G or E becomes E or G. You can go back and review. But I'm going to trust my vague memories here as I'm thinking about too many things at once and say, I'm almost certain commutation is the name of that rule. So this is a commutation rule on line 7. All right, so now I think we can do a conditional proof somewhere. Now, where are we going to do the conditional proof? All right, we're going to use E or G to somehow get to tilde F or G, which means I think we want to do a conditional proof on E and then show that that gets us to tilde F. Actually, we don't need to do that. Let's just go ahead and do a simple hypothetical syllogism. No conditional proof yet, but we may use one. Hypothetical syllogism on lines 3 and 4 gives us if E, then tilde F. And now I'm going to go with Mark's suggested strategy. Keep in mind that not always, but usually, once you use a premise, you're not going to need to use it again. Never on your homework or an exam cross out a premise you've used. That will just confuse your teacher, unless you're doing it with a very light pencil and you know your teacher doesn't mind. But maybe a check mark to the side of it would work, or if you're typing it like I am, a temporary crossing it out, as long as you don't forget to fix it, might be good. What steps have we cited so far? 1, 2, 3, 4, 5, and 7. We've already cited steps 1, 2, 3, 4, 5. All 5 of them. 1, 2, 3, 4, 5. And 7. Good. So we probably will not need to go back to these. So probably all we need is steps 8, 9, and 6 to get to our final conclusion. I'm going to pause, and after all that thinking and getting confused, instead of saying, oh, I need to do that conditional proof, I'm going to stop and wonder, was it the wrong strategy, or was it a good strategy, but I've ended up taking a different route now? Maybe. Let's do our working backwards rule and see what we can do. If we're looking for tilde I, we want tilde F or G. How do we get to tilde F or G? Well, we have E or G. And then we have if E, then tilde F. It's actually very simple. I just need to find the right steps to show it. And it's probably a very simple set of maybe 2 steps. Maybe a total of 3. If my brain is still telling me try a constructive dilemma. E or G, if E then tilde F, if G then G. How do I get if G then G? Well, off the top of my head, I can't remember that we have a rule that allows us to say if a statement then itself. If we did, then we'd be allowed to do a constructive dilemma, either E or G. If E then tilde F, if G then G, therefore either tilde F or G. And then by modus ponens on that, we can get to our conclusion. So this is not a rule I know. It would be a very useful rule for right now, but it's probably better if we don't have it in our set of rules, because I don't think I've ever needed to use this rule before. At least it doesn't ring a bell. So I think I want to get G arrow tilde G some other way. I think I can do it. Let's see. No, that's not going to work. That's not going to work. Got it. I got it. It's so ridiculous and simple. The simple way to get to if a statement then itself without having a special rule, is just use the conditional proof rule. When you need it, here's where you need it. We assume G. By the reiteration rule on that assumption, we can conclude that if G then itself. And now we can do our constructive dilemma. Now, my advice that often works, but don't assume it always works because there are exceptions, and we saw one or two videos back, is that once you use a premise, you probably won't need to use it again. So, what have we used? Just that. So what have we not used? Well, we're trying to use this, but we're not ready for it yet. We're trying to get this antecedent. We can get it now with a simple constructive dilemma, either E or G. By constructive dilemma on either E or G, and then lines 9 and 11, which tell us if E then tilde F, if G then G, then either tilde F or G. There we go. That's constructive dilemma on lines 6, 9, and 11. Either E or G. If E, then tilde F. If G, then G. Behold, tilde F or G. Now, by a simple modus ponens on the only two things we haven't used yet, we get to our dang conclusion. Tilde F or G. If tilde F or G, therefore tilde I. The simple modus ponens. And that's it. Could we be done with this video? Yes, we certainly could. All the same, kind of hate this. I do not like how convoluted this got. I want to do this in a different way. I'm going to do this in a different way. I'm going to do first some simple hypothetical syllogisms. Now, the rest of this video will hopefully be me giving a simpler proof. Let's do some simple hypothetical syllogisms. If tilde L, then E, and if E, then tilde S, and if tilde S, then F. That gives us if tilde L, then tilde S, and if tilde L, then tilde F. That's hypothetical syllogisms on lines 2 and 3, and then hypothetical syllogism on lines 7 and 4? 2 and 3, tilde L, if tilde L, then E, if E, then tilde S, therefore tilde, if tilde L, then tilde S. Yep, hypothetical syllogism 2 and 3. And we probably won't need those again. Now, hypothetical syllogism on 7 and 4. If tilde L, then tilde S, if tilde S, then tilde F, does indeed give us if tilde L, then tilde F. And we probably won't need those lines again, 7 or 4. Again, be super careful with crossing out lines you've used. Don't do it permanently. Uncross it out when you're done. Just do it as a reminder to yourself which lines you're most likely to still need. And bear in mind, sometimes you need to use a line more than once. So now, tilde. Oh, it's so simple. Once we do the hypothetical syllogisms in advance, I think we just go straight to a constructive dilemma. L or tilde L. If L, then G. If tilde L, then tilde F. Therefore, G or tilde F. Ridiculously simple. Constructive dilemma on lines 1, 5, and 8. L or tilde L, if L, then G, if tilde L, then tilde F, therefore G or tilde F. And then we're 2 steps away from the final conclusion. And one step is just switching around G and tilde F. My brain keeps telling me that that rule is called commutation. I'm very tired. I wouldn't trust my brain to not commit it. I guess it's the equivalent of a typo. The rule totally works, and commutation seems a perfectly reasonable name for it. It wouldn't shock me if my brain was getting the rule name wrong. All right, so now the rest is really simple. If you have any difficulty seeing how you can apply a modus ponens to lines 6 and 10 to get your final conclusion, then I suggest you add some parentheses to line 10. That should make it a little clearer. Tilde F or G is an antecedent. It's the if clause of premise 6. Tilde F or G is what you have in premise 10, or subconclusion 10. Since every step of a proof between the premises and the final conclusion is a subconclusion. It's a premise with respect to the final conclusion. It's a conclusion with respect to the premises that came before it, with the exception of that assumption step of a conditional proof or reductio proof. And now, speaking of reductio proofs, let's do this one day more time, and let's do a reductio proof because they're awesome. Let's assume tilde, tilde, I, and show that it leads to disaster. It leads to a contradiction. Now you can see how we're going to do this, right? Tilde, tilde, I. We're going to show that a contradiction follows from it. We can't look at this conclusion yet because that's what we're going to get at the end. Whatever is the final number here, it's going to be awkwardly triple tilde I, and then we're going to do a double negation on that. To get to tilde I. And we'll get that triple tilde I by reductio ad absurdum on lines 7 through whatever is the last number of that subproof. All right, so tilde tilde I is only relevant to right here, to the consequent of that last premise. And you can see how it applies, modus tollens. Well, I hope you can see it. We're going to get a denial of this, a denial of that antecedent. Oh, by the way, we state that this is an assumption. We're assuming tilde tilde I. And that gives us by modus tollens on 6 and 7. Tilde, open parenthesis, tilde F wedge G. Now, what on earth are we supposed to do with that? I don't know how to tell you what to do with that, except to just tell you. I'm too tired to explain it if there's a way to explain it. But looking at it, I can tell De Morgan's. We're just going to have to De Morgan's this. There's no alternative here, and it just feels right. So not F or G means neither not F nor G, which means not F and not G. Now I must pause and think, oh, dang, I need a dot. I need a dot symbol to go right here. That would be a De Morgan's on line 8. But I need to pause and find a dot symbol. All right, I found a dot symbol to copy and paste. So now, again, I could probably pause and explain this, but I'm not gonna. It's fairly clear that you're going to need to simplify these out of their conjunction. You're going to have tilde tilde F and G by themselves. That's both going to, those are both going to be a simplification on line 9. Another good example of why you should not automatically assume that once you've used up, once you've used a premise, you've completely used it up. You can usually assume that once you've used a premise, you're not going to need to go back to it. But in this case, you used 9 twice. So there you go. Now, let's see. I made a horrible mistake here. My apologies. I had a typo here. And therefore there as well. When we apply De Morgan's to line 8 here, not the case that not F or G. That means not the case. That means neither not F nor G, which means not F and not G. I had not F and G. That was a horrible typo. I'm sorry. Now I fixed it. So now you can probably look at this and see where to go. Where does not G appear? If you like, X out lines 6, 7, 8, and 9 because you've used them. And you're not likely to need them again, except don't X them out permanently. All right, so now looking at this, tilde tilde F and tilde G. Where do you find those things in the premises or find related information? Well, right here. It's going to be a string of short modus tollens to get us to where we need to go. Tilde G and number 5 by modus tollens give us tilde L. And I probably won't need those premises again. And then tilde tilde F is going to give us tilde tilde S when we use it in a modus tollens on lines 4 and 12. If tilde s, then tilde f. If not s, then not f. Not. There we go. Cited the wrong step. Line 10, not line 12. If tilde s, then tilde f. If not s, then not f. Not f. Therefore, not s. And now some more modus tollens. Not s applies by modus tollens to line 3, giving us not e. Fe, then not s, not s. Therefore, by modus tollens on 3 and 13, not e. And you can see where we can go with the not e. And I should possibly be pausing to do something with this not l, but I'm not. My brain wants to go to not e, and I'm going to do that. By modus tollens, then on line 2 and line 14, not L. Hey, we're just about done. Now check that last step, line 2. If not L, then E. Line 14, not E. Therefore, not L. And we're not likely to use those premises again. And now, I think we're just about done here. I think we can go straight to a contradiction. You could do a double negation on line 15 if you like. Although we don't have to. We can just say, by conjunction on our tilde L and tilde L, which is lines 12 and 15. By conjunction on lines 12 and 15, we get L and tilde L, which is our contradiction. Therefore, our assumption of tilde I was false, therefore tilde I. And therefore tilde I by reductio ad absurdum proof on lines 7 through 16 and double negation on line 17. And I think we're done here. Let me just pause to look through something because I'm really puzzled why we didn't end up using this. Let's see. If tilde L, then all this stuff. L, then all this stuff. I think we didn't actually need premise 1 to be explicitly used. You won't always use every premise. Now, there are great ways of doing this proof using this premise. We already did 1 or 2, didn't we? But, well, one of them was great. The other was ridiculous. But you could totally use this premise. But you don't have to use it because it's what we call a tautology. It can't be false. So by the time you follow through on these things, tilde L, if tilde L, then etc., tilde F, and if L, then G, and if either of those, then tilde I. By the time you follow through on the logic of assuming that conclusion is false, you've already reached a contradiction. And you don't need the tautological first premise that guarantees L or tilde L. It's always guaranteed. And that's why this contradiction works in our reductio proof. If you don't understand what I just said, it's fine. My suggestion is, if you, like me, were puzzled, why didn't we end up using this premise? Shouldn't we always use the premise? Well, you don't always use every premise. And even though we did in earlier versions of a proof of this, my advice is don't worry about it. But I'll try to say it one more time and then just shut up. This premise is a tautology. It can't be true or false. It can't be false. It has to be true. And we're actually using that tautology here in our reductio subproof implicitly. Even if we're not explicitly appealing to it as a premise, we're still using it because that's how logic works. In fact, the falsity of our contradiction here means the same thing as the proof. Sorry, as the premise 1. The tautological premise 1 means the same thing as the falsity of tilde L dot tilde tilde L. And you know what? I think that's so much fun. I'm going to just say it. I'm going to type it up even. It should work out just fine. I want to show that these are equivalent. I want to show that the falsity of L dot tilde tilde L means the same thing as L wedge tilde L. Don't watch this if you're not nerd enough, or if you don't care, if you don't have time. All right, so I want to show that the falsity of this, which means that, means the same thing. So if you don't know what to do with this, De Morgan's. With something like this, you definitely want to do a De Morgan's, which is going to give you a tilde tilde L wedge tilde 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 L. And then with a couple of double negation steps, you can get first L wedge triple tilde L, and then L wedge tilde L. Ta-da! All right. Thanks for watching.